My name is Boris, I'm from Aligned, and I am very excited to be sitting down with Shresth, the CEO and co-founder of Pod Network.
Thanks for inviting me here.
Yeah.
Glad to chat.
Yeah. So let's jump right in. Tell me about Pod, or tell me about yourself, actually. I'd love to hear a bit about your background and then the story behind Pod.
Sounds good. So I've been a builder in the space. I've been here and in the Web3 space for 6 years. I started with peer-to-peer systems. I was very curious how you can just build computers that suddenly start talking to each other and then they're alive in some ways. Got into IPFS and Filecoin, libp2p. And very early on, I started working for DAOs and then joined some DeFi protocols, built DeFi protocols that held hundreds of millions of dollars, and was there in that whole DeFi bull run. So I was gas golfing, building smart contracts, and then went kind of down the stack. And I was very curious how Ethereum worked. So I learned cryptography, I learned consensus protocols, and did a lot of consulting around that. I used to work at Common Prefix, which is a science-based consulting firm. And during that time, I worked with L1s, L2s, cryptographic protocols. And at some point, we were collaborating with Flashbots. We're trying to figure out a way to decentralize their auction protocol, the Suave protocol for PBS. And none of the existing consensus protocols was fast enough. Consensus protocols, they do not provide the guarantees you need. The guarantees that they provide is over a more longer for censorship resistance and so on. So we came up with a protocol from first principles. And we were staring at the board. My chief scientist, ex-chief scientist, Dionysus, who's the CEO of Common Prefix, he came up with the protocol. And we're staring at the board, and it seemed too simple for what it does. It felt like we're missing something. And then we kind of went down this rabbit hole of figuring out what could this protocol do. And we realized it's quite powerful, and it's just a new way of thinking about Web3 networks, which do not look like blockchains, but if they were invented today, this is how they would look like,
Without the technical debt of existing blockchain architectures.
Exactly, without the technical debt of existing blockchain architectures. Like if you were just building a Byzantine fault tolerant database, a global database is Byzantine fault tolerant, you would not have blocks. You would not have global consensus. You will not even have chaining. And if you let go of all of these kind of pre-built conceptions about blockchains that come from the Bitcoin era, because Bitcoin had to be in that way to allow for proof of work and to allow for all of those things, you end up at something which is way more fast. It's completely streaming. It looks very much like doing an API call, but not to a single server, but multiple servers at the same time. And then it's very instantaneous, and that comes up to be a new trade-off to build Web3 networks, and we're quite excited to kind of get the opportunity to explore it and see where this leads to. Yeah, that's how Pod came to be, and it's a new L1, it's programmable infrastructure. It's not a blockchain.
It's not a blockchain.
It's not a blockchain.
I was going to ask you, how is Pod different from existing blockchains?
Yeah, so I get this question quite a lot. So in a traditional blockchain, what happens is you have transactions. These transactions go through, let's say, a pipe, and when they get out on the other side, they are chunked into blocks, and every transaction gets an index. So every transaction has index. So if you send a transaction, nonce, exactly, and they're totally ordered. So if I pay for a coffee here in Argentina versus if Vitalik pays for a coffee in China, even though these transactions are completely independent, they would have to wait for one another. And that creates a lot of scaling problems. If you're from traditional databases, or if you've worked at Web2 companies, you know about locks. You never acquire a global lock to a database. You only acquire a column lock or row lock or lock that for the data points that you need. So with Pod, what happens is, by default, transactions are not ordered. So you have a set of transactions instead of an ordered set. And there is no block. So transactions are confirmed instantaneously. There's no block time. As the validator sees your transaction, it immediately signs, validates, and confirms. Like if you call an API, it doesn't wait for 200 milliseconds to respond to you, right? You call an API, the API immediately responds to you back. Same way, there's validators. Validators get your transaction, they immediately respond to you back in a streaming fashion. Versus sequential, chunked into blocks. Which means that validators might see transactions in different order, but then the system guarantees that eventually they will agree on the state. So instead of strong consistency, you get eventual consistency. And that's already enough for most of the blockchain applications that we use today.
I guess the design you're describing for Pod, it sounds like it's inherently parallelized.
Yeah.
And doesn't have the latency that we're used to with blockchains as most people know them.
Yeah.
Without getting too deep into the details, I'm curious. I'm going to dig into your docs after this.
Definitely.
And we'll add a link in the video as well for that if we want to go deeper. Like, how do you avoid things like the double spend problem if everything's happening at once?
So let me just kind of go over the life cycle of how a transaction is confirmed on a blockchain versus on pod, right? You send a transaction on a blockchain, it goes to a mempool. Then a block leader comes out. It takes a transaction, waits for the next block, sends it to a bunch of validators. They talk among themselves for several rounds. And at some point, the transaction is finalized, you know the coffee was accepted. The payment for a coffee. On pod, there is no mempool. You send a transaction directly to the current set of validators. They immediately sign, they send you back, they don't talk among each other, and the moment you receive enough attestations, your transaction is finalized. So this is like one network round trip. It's same as like you calling an API service, responding to you back, but now you're calling like hundreds of them, and you just wait for enough responses. So coming back to your question on the double spend problem, it seems that double spend actually does not need total ordering. Okay, so let's take a simple example where I was talking about payment, right? So if I'm paying for a coffee here in Argentina versus Vitalik paying in China, these are independent transactions, right? They do not have to be ordered. Double spending problem only comes when I am trying to spend the same money twice, which means only my local transactions have to be ordered. So as long as my local transactions are ordered, there's no double spending problem.
Okay, so you're buying 5 coffees at once.
Yes.
So those need to be ordered.
Exactly.
Like 2 cash registers, and you're paying in both. Those need to be ordered.
Exactly.
But outside of that,
It doesn't
it's not
matter.
an issue.
Exactly.
Interesting. Okay.
So if you look at local ordering, if a user assigns a nonce, which we have, if you know Ethereum, user has to assign a nonce to its transaction. So if I assign the same nonce to 2 different transactions, what would happen is you would not get enough attestations in the transaction.
That you've sent the transaction.
Exactly. They will just say, I've signed this one and I'm not going to sign the other one with the same nonce. So a quorum is enough.
Okay.
So just the quorum of people saying, hey, this is the first thing that has this nonce already solves the double spending problem. Which is kind of like, if you read the Bitcoin paper or Ethereum paper, the whole motivation about the consensus protocol was like, how do you solve double spending? That you need this kind of consensus machinery to solve the double spending problem. That's just a myth.
That is spicy.
Yeah.
And I feel like you probably get that reaction.
We have this blog which was quite, it got quite some popularity where we start with saying Bitcoin and Ethereum has lied to us.
That's a good way to get attention.
I even take a screenshot from the white paper of Ethereum which says, to solve the double spending problem, we need consensus and global ordering. And that statement is just scientifically incorrect.
Interesting. At least, well, maybe at the time they didn't think that there was a different way, but
these are last 5-6 years of research literature, such as consensus number of cryptocurrencies, one, fast pay, sui lutris. This is something we didn't come up with this. I don't want to take credits for, Pod did not come up with this. There's amazing work done in the research literature which shows this is possible. We somehow stumbled upon it independently and then found the research literature and we were like, this has to be productionized. This has to be taken to the world. Yeah. And that's what we're doing.
I mean, let's talk products then. So Pod is not a blockchain, but it is a decentralized, programmable smart contract network, right?
Yeah.
So naturally, there's going to be apps on this, right, to enable things like payments or DeFi. Can you tell me a bit about the use cases that you are thinking about or that you're excited about or that you hope people will build using your infra?
So there are some use cases that we are very excited about and we look forward to see them being built in the next 4 months to a year scale. Okay. And then there are some long-term use cases that we have in mind. I know that our infra would be very good for, but I feel that they will come up more in the 3 to 5 years timeline. So let me start with the hot use cases that we're excited about. I've been using this example again and again, but payments and stablecoin payments are massive. And as I've been saying, payments do not need total ordering. They only need local ordering, which means they're a perfect use case for Pod. And we would love for people to build payment rails, payment infrastructure on us. And we can achieve latency that is going to be the best you can achieve for a decentralized system. And then the other thing is fast auctions and fast markets. So just giving a little bit of intuition, if you think of auctions, the ordering of bids does not matter in an auction. It's only the set of bids you care about. And if you have an agreement on the set of bids, it's enough. Again, their Pod can be very good. And once you have an auction, you can build fast order books that use auctions to match and settle. So kind of giving a little bit of alpha, something that's going to come out very soon is a native order book on top of Pod that will process over 300K orders per second, 100 millisecond tick times while being decentralized. It's not a sequencer based system, it's a network. And more on this will come soon.
Stay tuned. So I mean, an order book, like a centralized exchange, for example. How would this compare to the throughput of a centralized exchange? I actually have no idea. What is Binance's,
Right. So So I've been looking into like the comparison we are having with NASDAQ, you know. So NASDAQ is like doing 1 million operations a second.
Okay.
And the fastest chains, right, like fastest decentralized chains, I'm not talking about sequencer-based L2s, but like actual networks, right? Like if you look at Monad, that's claiming 10,000. Solana maybe has seen like 4,000 or 5,000 in the real world, right? They claim higher, but they've seen that in real world.
And when you're trying to sell the tokens,
exactly,
it's congested and you can't.
Exactly. The volatility hits, it's unusable, right? So if you want to bring NASDAQ level markets on chain, there is like 2 orders of magnitude that we need to improve, right? From 10 to 100, 100 to 1 million. And I think pod can achieve like 300, 400. I mean, we are getting on our test networks, which are still geo-distributed. But I know that once we go to production, these numbers will be like, you know, way different. So I'm hoping we will still be in the range of a few 100K transactions, orders per second, while maintaining like very low latency.
About the network as well, I mean, I think I could ask you questions about this all day.
Yeah.
Don't want to keep you too long, but I am curious. So, you know, you're of course going to be limited by physics.
Yeah.
At some point.
It's just the speed of light.
Yeah.
Yeah.
And so geolocation is important. So in terms of decentralization, do you have a sort of target for validators? Is there, I don't know if you can share like performance requirements you expect. I think a lot of people will be excited to start thinking how they can contribute to this network because it sounds really useful.
We expect that the validators will be geo-distributed. We want to promote geo-distribution, and we don't expect that these validators will be Raspberry Pis, right? We're not in the Ethereum era. We expect these to be data centers. We expect these to be heavy machines capable of like handling this performance, right? For example, you cannot process few hundred transactions per second if you write to disk. It's just not possible. The disk read writes is just slow. You don't have time to like, you know, everything has to be very optimized, fit in a single UDP packet, running in memory, right? Which means that the node requirements is going to be much higher, right? Everything is going to be exactly a lot of RAM, a lot of bandwidth, memory requirements, and so on. We even expect people to build like custom CDNs so that you can provide lower ping times for your own validator and so on. So that's kind of the high level gist, but we will see more when we deploy it in live and we get the actual numbers. There's going to be probably trade-offs on like how big the machine is going to be versus the demand we see.
I see. Yeah.
But we definitely want it to be geo-distributed and heavy machines capable of handling the load.
Gotcha. Yeah, so I mean, you said you have a DevNet right now, closed private DevNet. Internal.
It's a public DevNet actually. It's a public DevNet. People can play with it. We have a few partners trying it out.
Okay.
And we want to move to a beta mainnet next year. So stay tuned for that.
Exciting stuff.
Yeah.
Man, Shresth, well, I'm going to leave some interesting stuff for people to discover on their own, because I know you have some great blog posts, and I'm sure the docs are great. But, you know, since we're talking about trade-offs in crypto and different things that this technology enables, I mean, just sort of from a high level, taking a step back, like if you could change one thing in crypto, what would it be? What do you think crypto needs to kind of take things to the next level, get mass adoption, scale? In general.
I feel like crypto sometimes tends to be too purist, where we keep ourselves to quite high standards, to not be opinionated. While if you look at all good products in the world, they take feedback from the users and make opinionated choices, make certain trade-offs. One of the major reasons why I feel that Web3 is not getting the adoption is because we are seeing adoption in certain areas, but we don't make trade-offs to make those areas better. For example, I believe that the strong PMF of crypto is around finance, particularly trading and payments. I think crypto has shown that anybody can start a market in a fingertip. Like you can go and launch a Uniswap market without trusting anybody, without asking anybody, right?
Yeah.
It's beautiful, right? Nobody could like imagine you could say that you could list your stock on NASDAQ without asking anybody. That's like crazy, right? In the traditional world, but Web3 has shown that you can do it. People can trade it without trusting you. Similarly for payments, right? You can just pay anybody any amount. You can open a bank account by just locally creating a public-private key pair. I think we should just embrace this. Like this is where the PMF is. Like just build infrastructure that is very optimized for that and make trade-offs that allow us to just capture this market. And it's okay if, you know, you're not generic L1 that is going to be better for everything, but is making certain trade-offs. So yeah, I think People need to think from first principles to build infrastructure that is opinionated for these things and build adoption for that.
Spicy. I'm sure some people are going to have opinions on this. But again, my personal opinion is that multiple approaches to these same sort of problems can exist simultaneously and will exist simultaneously. And there's a huge need for, let's say, transaction throughput in the world if we want to upgrade from centralized, trusted systems, which I'm sure we can all agree are important. Shresth, so wrapping things up, do you have any calls to action, things you'd like people to do or see, things to, keep watch for? I'm not sure when this is going to air exactly, but, for whoever's watching.
Definitely. I think we're building some very exciting stuff. You're going to put the links, but, keep your eyes open on the pod Twitter, and we will be releasing our order book. Would love people to build more exotic markets on it. We think that this is going to enable builders to build centralized exchange-like, NASDAQ-like markets from day one. It's not just AMM, but it's actually a fully on-chain order book with all of the performance, with margin, liquidation, and all of those things that you only get on a centralized exchange, but now it's going to be in a decentralized way and anybody could launch it. So it's going to be quite powerful, and I hope people build cool stuff and give us feedback and build with us. So
beautiful. I love it. Shresth, thank you again.
Thanks a lot for inviting.